Okay, so Leetcode practice time. In this video, there are two goals. The first one is to find the solution for this specific question, and we are going to do some coding work for it. And the second one is to see how to solve this problem properly during an interview. So let's get started. The first step is always to try to understand the problem. If there is anything unclear to you, please bring up the clarification questions to your interviewer, and at the same time think about the edge cases. So let's read the problem. It asks exclusive time of functions. So on a single threaded CPU, it executes a program containing n functions, and each function has a unique ID between 0 to n minus 1. And function calls are stored in a call stack. When a function call starts, its ID is pushed onto the stack, and when the function call ends, ID is popped off the stack. Okay, so the function whose ID is at the top of the stack is a current function being executed. And each time a function starts or ends, we write it log with the ID, whether it starts or ends, and the timestamp. Okay, so let's take an example. Take a log entry example. So for example, the log entry looks like 0, start, and 3. That means the function id 0 started at the beginning of timestamp 3. Alright. Similarly, for 1 and 2 means function id 1 ended at the end of timestamp 2. Okay. So note that a function call can be called multiple times, possibly recursively. Okay, and the function's exclusive time is the sum of the execution time for all function calls in the program. For example, if a function is called twice, one call executing for 2 time units and another call executing for 1 time unit, the exclusive time is 2 plus 1 is equal to 3. Alright, so the problem is asking us to return the exclusive time of each function in an array, where the value of the s index represents the exclusive time for the function with id as I. Okay, so let's take a look at this example 1. So we have 0 start 0, 1 start 2, 1 and 5, 0 and 6. So of course, based on the log entry and the graph, it says that 0 first function 0 takes 2 units of times before function 1 gets scheduled. So function 1 started at 2 and ends at 5 takes 4 units of times. And then after function 1 finish executing, function 0 restart to be executed and end at timestamp 6. So in total, for function 1 it takes 3 units of times, and for function 1 it takes 4 units of times. I think it's pretty clear to us. There might be we may need to clarify some constraints. So first of all, n is between 1 to 100, so it means there is at least one function, and the log entry is not going to be empty. It's between 1 to 500. Okay, so function id is between 0 to n, so we don't need to worry about like the illegal inputs for function. So, and another thing is timestamp is between 0 to a billion, and there will be no two start events will happen. So no two start events will happen at the same timestamp, and no two end events will happen at the same timestamp, because it is only single thread CPU. So yeah, so this essentially tells us that the log is going to be legal regarding this perspective, and each function has an end log for each start log. Okay, so there is for sure a closing one for an open task, for an open function. Okay, so I think we don't need to worry about the illegal inputs, so we don't really have too much to think about the edge case at this time, I think. And the next part is about finding solutions. So in this part, you communicate with your interviewer about the ideas to solve the problem and talk about the runtime and space complexity analysis. So let's see how to solve this problem. So I would say we could use a stack because essentially this is a call stack problem. So we can use a stack. Let's say we have the stack, so the left part is the bottom of the stack and the right part is the top of the stack. Let's say we have a stack and we record the timestamp the task started. So let's say the start timestamp, and also this is the stack and start timestamp, and also we will have the return array, which we call it exclusive time array. So let's see, at the very beginning the exclusive time array will only contain zeros. So let's take example 1. So we will have exclusive time to have 2 zeros because there are only 2 functions there. And at timestamp 0, function 0 started. So we put 0, which is a function ID, into the stack, and we say, okay, the start timestamp is equal to 0. And then function 1 started at timestamp 2, then it means that function 0 has ended at timestamp 2. So it is going to, so function 0 has already taken 2 units of times. So we are going to first update the exclusive time for function 0 to be 2, and then we are going to push function 1 into the stack, and at the same time we will update the start timestamp to be 2. And then when we see the log entry 1 and 5, then it means the function 1 has already ended. So what we are going to do is we will pop function 1 from the stack, and we will compute the execution time for function 1 at this time. So function 1 starts at timestamp 2 and ends at timestamp 5. So we will say, okay, function 1 takes 4 units of times to be executed, and we update the start timestamp to be 5 plus 1, which is 6. And similarly, we see that function 0 ended, though then we pop the stack, the top element of the stack, and also we see that the start timestamp is equal to 6 and it ends at 6. So this time it takes 1 unit of time, and we are going to update function 0 with the other execution time unit. So we are going to set function 1's exclusive time to be 2 plus 1 is equal to 3. So for this approach, it is going to be O of m. So m is the log entries, the number of the log entries. So I think we are good to go. Let's get started and do some coding work on this approach. So for coding part, we care about the correctness, the speed, and the readability of the code. So let's see. First of all, we will need to initialize the array. So let's say it is called exclusive times, and let's say it is going to be new int n. Okay, and we are going to iterate, and we are going to have the stack of the integers. So let's say function stack is equal to new stack. Okay, that pretty much finishes the initialization of the parameters to be used. And the first thing we are going to do is we need to push something into the stack. So first of all, we will say okay, function stack dot add logs get 0. No. So first we can first of all we need to define helper function, which is going to return the function ID, whether it starts or end, and also the timestamp. So let's define a maybe a class. Let's say private class. Let's say log entry. So let's say we will have three things. The first one is the function ID, and the second one is whether it starts or ends. So let's say we have the boarding, say is start, and then the other thing is the corresponding timestamp. So we will, alright, so we will also have a, let's say a constructor for it. So public log entry, so it will be string, let's say the log. Okay, so we will pass the log into the three fields. So string is equal to log dot split with the colon. So ID would be, and we would be integer dot parse int it would be entry 0, and this dot is start would be equal to entry 0 dot entry 1 equals if it's start or end. So, and the timestamp would be equal to integer the parse int entry 2. Alright, so that's it for it. And first of all, we will have the first log entry. So log entry log would be equal to new log entry log. Okay, so logs dot get 0. Then we will say okay, we need to push the function stack dot add, which is log dot id, and of course we are going to have the timestamp. Let's say func start ts as equal to log dot timestamp. Okay, so that finishes the initialization of it, and then let's step into the loop. So I is equal to 0, I is equal to 1, I is smaller than logs dot size and plus I. Okay, so log entry, let's say one log is equal to new log entry logs dot get 0, or just maybe we can just reuse the previous thing, which is log is equal to new log entry okay, logs got I. Okay, so this is the log entry, and we'll see. So if log dot, if it is a start of a something, if it is a start of a something, we need to calculate the current runtime of the function at the top of the stack. So we will say, okay, function ID would be equal to stack dot okay, so it is called func stack dot peak. So it is going to pick the function ID, and we are going to say, okay, the runtime would be log dot timestamp and minus the func what is that? It will be equal to, it should be equal to func star ts. Okay, and then we compute the runtime, and we are going to say that so exclusive times func ID plus equal to the runtime. So we update it, and at the same time we are going to update the function start ts as equal to log dot timestamp. Okay, if it is the end of the task, okay, so we also need to update the stack at this time. So func stack dot add the log dot id. Alright, so if it is the ending task, then what we need to do is so first of all, we will pop the task from the stack dot pop, and then the other thing is we need to compute the runtime for it. So the runtime is going to be log dot timestamp minus function start ts plus 1, and the exclusive times func so the func id is actually the log dot id is equal to plus equal to the runtime. So we pop the stack, we update the exclusive time of the corresponding function ID, and also at the same time we will need to update the func start ts is equal to log dot timestamp plus 1. Okay, so I think that should be pretty much it, and finally we will return exclusive times. Okay, so after we are done with the code, we need to do some testing. So first step for the testing is to manually go through a simple example, at the same time explain how this piece of code works to the interviewer. So this is about doing some sanity check, and the next part is about indicating what other test cases you're going to set up to have good enough test coverage. So let's say for let's still use example 1 for this one. So at the very beginning, we will see that the stack is first of all initialized as empty, and the exclusive times is equal to 2 zeros. Okay, so if we initialize this as our zeros, is it, maybe we need to do it, but I guess we don't need. So I is equal to 0, n smaller than n, the plus plus I, so exclusive times I is equal to 0. Okay, so our zeros, and we have the stack, and first of all we are going to push 0 into the stack, and then we will have func star ts set up as equal to 0, and then we iterate through the log entry. So we see that func1 starts at 2, so it is a start, and we see that the top element in the function stack is 0, so func id is 0, runtime is equal to 2 minus 0, which is 2, so runtime is 2, and we update the exclusive time to be 2 at this moment for function 0, and the func ts is equal to the log timestamp, which is 2. Alright, and we also update the stack with by iding the top element 1, and then the other entry is 1 and 5. It is an end. We are going to pop the top element from the stack, and we are going to say compute the runtime, which is 5 minus 2 plus 1, which is 4. So we update the exclusive time for function id as 4, for function id 1 as 4, and then func start ts is equal to 5 plus 1, which is 6. And then the last entry is 0 and then 6. It is end. We pop the stack, and then we compute the runtime as 6 minus 6 plus 1, which is 1. We update exclusive time for function 0 to be plus 1, so we are currently it is 3, and then func start timestamp is equal to 6 plus 1, which is 7. Okay, it's 7. Okay, I think we should be good, and finally we return exclusive timestamp. Let's give it a shot. Okay, so it's accepted. Okay, some runtime error. So let's say empty stack exception. So we have 0 start 0 0 end 0, 1 and 1 start and then a end. So why? So we are trying to pick. Okay, so if it is start, then we try to pick. Oh, okay. So when the stack is empty and then we try to peek, then that's essentially what it is talking about. So okay, so if it starts at 0 and at 0, and then the stack it becomes empty, and then we need to see, okay, now something started. No, it's something already started. Start from, so okay, start from 0, end from 0. Okay, so how to do it? So if the stack is empty, then of course we cannot really pick it. So instead, we should, so what should we do? If it is empty, if log is start, so if it is empty, we don't need to compute the runtime for it, and we also don't need to update the exclusive time. We just need to update the func start ts and add okay, so I think I understand what we should do. So we should put all of this into an if branch. So if star stack dot empty is okay, so maybe there's no now is larger than 0. So if the stack size is larger than 0, then we need to peek, compute the runtime, and update the exclusive time. And otherwise we don't need to do it, but we still need to update the func start ts, and we need to add the function ID into the stack. Okay, so let's try another submission. So it's compile arrow. So stack dot okay, so it's func stack. So func stack dot I think there should be a empty. Okay, so okay, if it's not empty, so run the code, it looks good, and then do another summation. Okay, so now it's accepted. So yeah, I think I missed the task case like indicated in the task case setup. So for example, 0 starts 0, 0 then end. So it's like every time, so it's not there's no interleaving function executions. So yeah, we definitely need to test that kind of task cases. So regarding the task case setup, I would say definitely set up something like interleaving tasks and non-interleaving tasks, and also something with recursive functions. Yeah, I would say if we do that, that should look pretty good regarding the task coverage. Yeah, so that's it for this coding question. So if you have any question, please leave me a comment. And if you see this video pretty helpful for your interview preparation, please give me a thumb up, and I'll see you next time. Thanks for your time watching it.